Hello friends, so today we are gonna learn the division by t theorem of Laplace transform. So what is the statement of division by t theorem? So it is like this: if Laplace of a function of t is equal to some function of s, then the Laplace of function of t upon t is equal to integration from s to infinity phi of s, that is function of s, ds. So now why this property is called as division by t? Because if you'll observe, then here we have function of t upon t. It means here the t is dividing our function of t. So since this t is dividing the function of t, we call this property as division by t. Now to prove that, Laplace of f of t upon t as integration s to infinity phi of s ds, will start with the Laplace of f of t equal to function of s. That is the definition. So here I'll say let function of s is equal to Laplace of function of t, and by definition we can say that function of s is equal to integration 0 to infinity e raised to minus st f of t dt. So this is the definition of Laplace transform. Now as we want property as integration s to infinity phi of s ds, it means we want integration of function of s with respect to s. So for that, what we'll do is we'll integrate both sides with respect to s, and by considering the limits from s to infinity. So here I'll say therefore integrating both sides with respect to s between the limits s to infinity. So therefore here we'll get integration from s to infinity phi of s and integration with respect to s, that is ds. Similarly on right hand side we'll get integration s to infinity, then this term as it is, that is integration 0 to infinity e raised to minus st f of t dt, and here we have ds. So here we are integrating the right hand side with respect to s between the limit s to infinity. So now to solve this and to get the value of this as Laplace of f of t upon t, what we'll do is we'll interchange the limits. So first of all we'll consider the limit from s to infinity for ds, and we'll shift this limit 0 to infinity of dt outside. So we'll get therefore integration s to infinity phi of s ds as it is. By interchanging we'll get 0 to infinity outside, s to infinity inside, e raised to minus st f of t, then ds inside and dt outside. So we have interchanged the limit. Now let's solve this integration first. So if I'll integrate e raised to minus st f of t with respect to s, then f of t is constant because it does not have s. So I'll take f of t outside. Then integration of e raised to minus st with respect to s is e raised to minus st upon minus of t, which is from s to infinity and dt as it is. Now let's substitute upper and lower limit. So here we'll get integration 0 to infinity as it is, f of t as it is, and in bracket we'll get, when I'll put s as infinity, here we'll get e raised to minus infinity, and we know that e raised to minus of infinity is equal to 0. It means when we'll substitute the upper limit, we'll get value as 0. Next, middle sign is negative, and now we'll substitute the lower limit. So lower limit is s itself, So when I'll substitute s in s, we'll get the same term, that is e raised to minus st upon minus t as it is into dt. So it means here we'll get integration 0 to infinity f of t, this 0, then minus and minus plus, so 0 plus e raised to minus st upon t is e raised to minus st upon t dt. Now I can rewrite this integration as integration 0 to infinity e raised to minus st and in bracket f of t by t dt. And now my friends, if you will compare this integration with the definition of Laplace transform, then you will find that it is nothing but Laplace of f of t by t, because as per the definition of Laplace transform we have integration 0 to infinity e raised to minus st f of t dt, and here now f of t is f of t by t, so it is nothing but Laplace of f of t by t. So it means we got the value of Laplace of f of t upon t as integration s to infinity phi of s ds, which is our division by t property. So here we have proved the property, and now we are going to use this property in multiple problems where we have the t in the denominator or a t which is dividing the f of t. So there we can apply the theorem and get the value by integrating function of s with respect to s and by taking the limits between s to infinity. Thank you.